All right, we can now look at in the results tab, look at this consumption overview report. This is the only report in this section. And basically it provides an overview of the data that you just entered in the consumptions tab. Again, if this is the data directly from the bills, you'd get a good estimate here, or a good viewing of all that information summed together and compared here in similar units. So the units have been converted so that you can see how much electricity was used and how much natural gas was used. Here these are in these numbers are very close, but then when you convert them into megawatt hours, you see that there's a big difference in the actual energy usage. This can give you a good perspective on where a lot of the time could be spent for the study. And we've got another report. If you look, we're in the details view here. We can plus these out and see grid views that will show that profile I was talking about, both in the energy perspective and the cost perspective. We'll scan down a little further and you can see the cost associated. So at times the rate could change from month to month, and you would see differences there as well. So that was for electricity, and similarly we can do the same thing for natural gas. Now if we want to look at them together and any other utilities that have been added, we can click graph and you'll be able to see them plotted together in this chart. You can see the energy usage, where we have the two different time series, basically plots for data, and they've been plotted together. So you'd be able to see the energy usage and compare it to each other, and also the costs. So this is something that could easily be done in Excel if you were just going to do it on your own, but it's built in as a feature this way so that you can see that data very quickly from the consumption. Now let's go back and look at the table view and talk about the most important purpose for this data. So normally we would go through the study and get to this point, click continue, save everything, and then we're going to go to run the facility models for all of those facility groups that we had just previously set up. Once those have been run, we're going to have baseline results, kind of status quo results for the as-is situation there. We want to compare those back to something in order to calibrate the model, to make sure, first of all, to verify, to make sure that it's close, and if there's some discrepancy, to find out what's going wrong and then recalibrate to the changes that have been made. So we use this data to provide a very rough look at where those numbers should be. These regions don't have to line up exactly with the region that you're looking at for the study. Many times we have installation scale data for the energy, for electricity and natural gas, but we're only looking at a subset of the installation in the study. But that's okay. We've got the square footage for each one of these utilities and the energy, and so we can get an energy usage intensity, an energy per area number for each of the utilities, and compare that to the energy usage intensity of our region that we're looking at. Now it's not going to be an exact fit for a couple different reasons. One, they're not necessarily all exactly the same buildings. You may have, as I mentioned, this data for a whole installation, but only be looking at a small section. At the same time, even the data that's rolled up at this point that comes in from the bills is going to include a lot of additional energy usages beyond the buildings. So things like street lighting, they aren't going to be associated with any, the street lighting's not associated with any given building, but it's still going to be part of what they're billed for. So what we want is to be able to compare those numbers. Hopefully they are reasonably close, and even beyond that, more importantly, we should be able to explain the differences. If we're looking at a section of buildings that includes a lot of warehouses, we'd expect to be under that average. And we'd expect to be under the average as well because that average included the things like street lighting and other aspects. If we have a very high energy density group of buildings that we're looking at with computing centers and things, we'd expect to be above it. So those are some of the things that just get us in the ballpark. We can still use individual building data, metering data, if we have it for buildings, and compare those to the building models. to make sure that those are very close. But this gives us a first line estimate to make sure that there aren't any mistakes. It is possible for someone to put in a number that's an order of magnitude off or something like that and cause kind of larger scale errors. And so again, we can use this data to make sure that we're close. And if we do find something like that, track back through the data and find out what input may have been off. So that's the primary purpose of this information, to validate those initial modeling results and provide a source for calibration. In the next section, we'll be looking at making changes to those initial inputs for the models for each building, in case there are any upgrades or changes to the buildings that would make it so that we should change those default models from their initial position and maybe adjust for renovations to lighting or to windows or something like that. All that will be covered in the next section.